Welcome to AI Frontiers. Today's episode covers machine learning breakthroughs. A day in AI. Synthesizing 83 papers from October 21, 2025. Exploring the latest in machine learning innovations, featuring the paper of the day. Steering autoregressive music generation with recursive feature machines. Presented by AI Frontiers. This presentation dives into October's machine learning pulse. Join the journey through 83 fresh papers, blending creativity, efficiency, and real-world impact. Themes like controllable AI and optimized learning are uncovered, spotlighting breakthroughs that redefine possibilities. Engaging stories from music generation to medical predictions are shared in an accessible narrative. By the end, the connections between these ideas and their inspiration for future innovations become clear. This serves as a guide to the cutting edge, exploring the ecosystem driving AI forward. Machine learning enables algorithms to learn from data, making predictions without explicit programming. Like teaching a child through examples, it handles patterns in vast datasets for decisions. It powers applications from Netflix recommendations to medical diagnoses and self-driving cars. Sub-areas include reinforcement learning, which involves trial and error with rewards, and generative models for creating content. These papers address efficiency, robustness, and real-world use, evolving AI toward human-like systems. A key theme is enhancing model controllability, giving users control over AI generations in creative domains. Zhao and colleagues enable fine-grained music steering without retraining, achieving 82% note accuracy. This extends to image generation, balancing identity via reinforcement learning. Challenges in art and design are addressed, making AI more intuitive for users. This overlaps with efficiency by minimizing compute needs for adjustments. This theme builds on activation steering, a technique to tweak neural signals for targeted outputs. It supports dynamic domains like music composition, reducing artifacts in results. Connections to broader AI safety are made by preventing unintended generations. Evidence from multiple papers shows controllability revolutionizing user-AI interactions. This sets the stage for themes in optimization by ensuring stable, directed learning. The second theme focuses on optimization and learning dynamics, refining how models evolve. This includes curriculum learning, ordering data from easy to hard. Zhao and colleagues reveal no universal strategy. It depends on model capability and task complexity. Biologically plausible methods unify gradient descent with neural adaptation. The aim is to prevent forgetting and instability in scalable systems. This links to controllability by improving adaptability during learning phases. The third theme emphasizes efficiency and compression techniques, making models lighter and faster. Parameter-efficient fine-tuning is used for edge devices. Zhang and colleagues achieved top performance with just 0.02% trainable parameters. Techniques like quantization-aware training cut memory by 60% on 23 tasks. Deployment on phones or wearables is enhanced without losing accuracy. This ties into other themes by enabling robust, controllable AI in resource-limited settings. Groundbreaking insights across papers include the finding that no universal curriculum exists for math reasoning. Adaptivity is key, as shown by Zhao and colleagues. Steering activations yields 82% music control accuracy, from Zhao and colleagues. Efficient fine-tuning slashes memory by 60% with minimal parameters, from Zhang and colleagues. Generalization metrics are fragile to tweaks, urging rigorous audits. Personalized treatments hit 84.3% accuracy using large language models and bandits. Common methodologies are synthesized here. Reinforcement learning involves agents learning via rewards, strong for decisions but compute-heavy. Attention mechanisms capture dependencies in transformers, memory-intensive yet effective. Curriculum learning orders data by difficulty, speeding convergence but context-dependent. Parameter-efficient fine-tuning adapts models with minimal updates, cutting parameters dramatically. These blend innovation with trade-offs like precision versus efficiency. The first selected research paper is the paper of the day, Steering Autoregressive Music Generation with Recursive Feature Machines, by Zhao and colleagues, from 2025. It is selected for innovative controllability in creative AI, advancing user-directed generation. Music RFM is introduced for activation steering, achieving high accuracy without retraining. Novelty lies in handling multiple attributes dynamically, with broad implications for arts. This represents a key direction in making generative models intuitive and artifact-free. The second selected research paper is What Makes a Good Curriculum: Disentangling the Effects of Data Ordering on LLM Mathematical Reasoning, by Jha and colleagues, from 2025. It is chosen for dissecting learning dynamics, revealing adaptive strategies over universal ones. Difficulty dimensions in large language models are analyzed, boosting reasoning through targeted ordering. This is impactful for scalable training, with open code fostering further research. It exemplifies the optimization theme, bridging theory to practical AI improvements. The third selected research paper is NeuroAda: Activating Each Neuron's Potential for Parameter-Efficient Fine-Tuning, by Jha and colleagues, from 2025. It is picked for efficiency breakthroughs, enabling edge deployment with minimal resources. Bypass connections are used for precise tuning, outperforming baselines on diverse tasks. Novelty is found in neuron-level optimization, reducing memory and compute dramatically. This represents the efficiency theme, paving the way for accessible AI in everyday devices. Future directions outline next steps in research. Hybrid models combining curricula with steering are anticipated for ethical, adaptive AI. Focus is placed on robustness against attacks and environmental training costs. Interdisciplinary fusions, like AI with physics for climate or medicine, are expected. Metric fragility and high-dimensional challenges are addressed through collaboration. Opportunities exist in personalized apps and smart cities, building on current insights. This deck was synthesized using AI tools. GPT Grok with model Grok 40709 for content generation. TTS synthesis was handled via Google for audio elements. Image generation was performed using Google for visual aids. Review was conducted by a human expert to ensure accuracy. Note that potential oversights may exist. All references are provided for verification. Subscribe to the YouTube channel for more deep dives into AI research. The title is AI Frontiers. The description states, your go-to source for synthesizing the latest arXiv preprint server papers into engaging narratives. Hit subscribe and turn on notifications to never miss an episode. Join the community exploring machine learning's frontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.